Alright, this is a tutorial video about reflections. I'm just going to go through a few example problems. There are a couple key things we need to get out of the way. I know you know what the x-axis is, and I know you know what the y-axis is. But from time to time they're going to refer to two other things. They're going to refer to the line y equals x. And you need to know that that is a diagonal line going up from left to right. It's right in the middle. Technically it is a 45-degree angle, but we probably won't need that information for this quiz. But it's right through the middle, going upward from left to right. That's the line y equals x. On the other hand, we have the line y equals negative x, which is also a diagonal line, but it goes right through the middle, going downward from left to right. Okay, so those lines will be used as reflection lines, so you need to know what they are. Okay, so let's look at this first problem. We have this figure, A, B, C, D, E, F. It was reflected across that line y equals negative x. Alright, so this figure that we're looking at is the result of that reflection. And they're mentioning that line y equals negative x, which we now know is a diagonal line going like this, downward from left to right. Okay, that's the reflection line. Now, what are the coordinates of the pre-image of point F? Okay, so focus your eyes on point F prime, which is right here. And they want to know what was the original point, the pre-image of this point. Well, basically we just need to reflect this point over this diagonal line, and then we'll know. So if we did that, it would land right here. I'm just looking diagonally across, and I'm going the same distance on the other side. So this blue point tells me what the pre-image would be, the original point. And I see that's over 1, and oh, I'm sorry, this got to be careful. Apparently they're counting by twos. So even though it's over 1 square and down 2 squares, that means it's actually over 2 units and down 4 units. Okay, so 2 units to the right and 4 units down. This would be that point. All right, let's reveal. And this was the correct answer. Okay, let's take a look at this one. Which statements must be true about the reflection of triangle XYZ across the line MN? Check all that apply. So let's see, angle x prime, z prime, y prime is 90 degrees. Let's see, where is that angle? X prime, z prime, y prime. So x prime, z prime, y prime, this is the angle that they're talking about. Alright, going in order with z in the middle, it tells you that this is the angle right here. Now, they gave us this box here in the original figure, and that means that z is 90 degrees. When you do a reflection, it doesn't change any of the angles. So if the angle z was a 90-degree angle, then the angle z prime will also be a 90-degree angle. So that should be true. Alright, so I'll put my check mark on that. What about the measure of angle MCY? Let's take a look and see where that is. You know what, maybe I can erase this now. Okay, MCY. So here's M, and here's C, and here's Y. So they're asking, is this angle right here a 90-degree angle? Well, this angle includes the reflection line and one of the points that's being reflected. So this line the reflection line, and then the line created if you connect the two, the image and the preimage. Those are always going to be perpendicular, because when you do a reflection, for example, from y to y prime, a reflection is always forming a perpendicular line. So from y to y prime will be perpendicular to the reflecting line. From z to z prime, perpendicular. Okay, guaranteed. From x to x prime, perpendicular. Every time you do a reflection, it's going to be a 90-degree angle. So that is also true. Now, what about this next one? From line segment x prime. All right, let me change colors on this one. So x prime. Okay, so we're talking about this right here, this green. You know what? I'm going to have to do better. Maybe if I make it a little thicker. Okay, so here's the line segment from x to x prime. And then from y to y prime would be right here. All right, the question is, are these definitely congruent? Are they the same length? The answer to that one's going to be no. There's no reason to believe that those are the same length. All right, we're just talking about mirror image points. For example, they could have easily, it's hard to tell because they look pretty close. But look at Z, for example. It's the same sort of situation. Here's a point, here's the image. If I connect those, is that line the same length as the other two? Are all three of these the same? No. So there's nothing telling us that these points connecting the image and the pre-image makes congruent lines. Sometimes they're closer, sometimes they're further. Sometimes they could be the same, but we don't know that. So we have no reason to think that these lines will be congruent. Now, what about BZ prime? Where's that? Okay, so here's BZ prime and BZ. Are those congruent? Yes, those will be congruent. This is a reflection, so it's going to be the same distance from the line to each of the 2 points. All right, the image and the pre-image are the same distance on opposite sides of the line, so those should be congruent. Okay, what about Z prime? Let's see, so Z prime is right here, and Y prime. Well, we basically just talked about that. Oh, actually, all right, they're not saying congruent. Now they're asking, are they parallel? That's what this symbol means. And yes, they're going to be parallel. These segments connecting the image and the pre-image are always perpendicular. All right, we did talk about that. And if you have 2 lines that are perpendicular to the same line, all right, they're both perpendicular to this blue line, right? So of course they're going to be parallel. All 3 of these lines, in fact, all right, I'll draw a purple line. Okay, the purple line, the pink line, and the green line are all parallel because they're all perpendicular to the blue line. All right, so yeah, those are parallel. What else? All right, last one. Sort of a long question because of all the pieces. Let's look at a segment XY, which is right here, and segment X prime, Y prime, which is right here. Are those parallel? Must they be parallel? No, they don't have to be parallel. You know, these lines going across had to be parallel. I talked about that. Now these ones, sometimes they'll be parallel, sometimes not. All right, they're just corresponding parts of the triangle. It'll make it really obvious if I pick any other side any other pair of corresponding sides. For example, if I pick y prime z prime, and if I pick yz, all right, those are corresponding sides. It's obvious that these are not parallel. So there's no reason why other corresponding sides have to be parallel either. Okay, so let's do the reveal. And we are all in agreement. Okay. A point has the coordinates 0, k. Which reflection point will produce an image at the same coordinates? Okay, so we want to do a reflection, but yet not change the coordinates. Okay, so first of all, 0, k. Can you see that that would be somewhere on the y-axis? Because 0 means over to the right, none, and then k means up k, assuming k was positive. So that's going to put it on the y-axis. Okay, so first of all, we know if you do a reflection over the y-axis. So if we use the y-axis as the reflection line, all right, the y-axis, well, if you have a point on the reflection line, it's not going to change. So that will definitely be an answer to the question because it's on the y-axis. Now, any other reflection, so for example, say if I did a reflection over the x-axis, that would be here. Oh, I didn't know it was going to move like that. Say if I did a reflection over the line y equals x. All right, a reflection over the line y equals x would be here. All right, that all of these things would change. Only a reflection over the y-axis is not going to move you because you're on the y-axis. All right, so that's why I believe the answer is B or whatever. Let's check it out. All right, that's why this was the answer, y-axis. Okay, still talking about reflections. All right, well, what do we have? What do we have? The image of trapezoid PQRS after a reflection over the line W equals Y is trapezoid P prime, Q prime, R prime, S prime. So, as you can see here. What is the relationship between R prime segment? Okay, let's see. This is segment R prime, and S prime. Okay, so we sort of talked about this above. These two should be parallel. All right, they're both going to be perpendicular to the reflection line. They should be parallel to each other. So that's what I'm looking for. RR is parallel to SS. Well, RR prime, SS prime. Boom! There you go. Let's keep going. What about this one? What are the coordinates of the image of vertex D after a reflection over the x-axis? Okay, so vertex D is right here. If we're going to do a reflection over the x-axis, we want to go the same distance on the other side of the x-axis. So this is 3 units below the x-axis. All right, so we're going to go 3 units above the x-axis, which would be right here. And the coordinates of that point should be the point 5, 3. So I'm saying the answer is going to be this first one, 5, 3. Boom! Looking good. All right, let's keep going. This is another long one with many parts to it. So let's buckle in. Focus. All right, which statements must be true about the image of triangle MNP after reflection over this line EG? Check all that apply. Okay, the image will be congruent. Yes, that's true. When you do a reflection, you're going to get a figure that has the same lengths and the same angles. So it's going to be congruent. What about the next one? The orientation. All right, orientation means how it's facing. Let's see, I think I can show this to you if I draw a new triangle. Okay, so if I take this and I just slide it over, no matter where I slide it, the orientation remains the same. It's facing the same way. If I go like this, though, now I've changed the orientation. It's not facing the same way anymore. Okay, so the question is, what about a reflection? Well, a reflection is definitely going to change the orientation because it's going to sort of flip it the other way. It's going to make it face the other way. I don't know if I can really do it. I'm going to try. Let's see, reflection. Let me do I can probably do it if I go like this. All right, a reflection is something basically, it would look something basically like this. Getting better. All right, I'm trying to approximate the reflection over this line. But notice it's not facing the same way anymore. The orientation has changed. It's facing backwards. So that's what they mean by orientation. So that's a no. EG will be perpendicular to the line segments connecting the corresponding vertices. This is what we talked about earlier. All right, these would be the line segments connecting the corresponding vertices. Okay, it would be like this. And yes, these should be perpendicular because that's how reflections work. So that should be kabam. All right, now the line segments connecting the corresponding vertices will all be congruent to each other. Well, that is not true. All right, connector, connector, and connector. All right, are all three of those going to be the same length? Obviously not, so on that. Okay, the line segments connecting the corresponding vertices will all be parallel to one another. Let's see if I can bring those back. Boom, boom, boom. That's a yes. All right, these line segments connecting corresponding vertices, they're all perpendicular to the reflecting line and parallel to one another. So that's true. All right, let's see how I did. Okay, I'm a genius. Well, you're supposed to be good at this. You're the teacher. You're right, you're right. I won't be proud of myself then. You guys are really mean. Let's see. What are the coordinates of the image of vertex G after reflection over the line y equals x? All right, there's that line y equals x. So we just need to worry about G. Okay. Now, there are formulas for this, but I'll mention the formula in a second because I really like to do common sense whenever I can. Now, you know what? To help me do my common sense, it would help me to see these lines that are being covered up. Okay, because what I like to do is count. All right, I'm going to count my way. I'm going to count the squares until I get to the reflection line. So I'm moving diagonally here. So this would be like 1, 2, 3, 4. All right, so it's 4 full squares. So if I want to do the reflection, I'm going to continue my diagonal motion 4 full squares in the opposite direction. All right, I'm going to start from here because these are mirror images, and in the pink direction, 1, 2, 3, 4. Now the blue direction, 1, 2, 3, 4. All right, so here's how you could do this just visually. Now, looking at the answer, it'll help us know the formula. But we forget formulas a lot. But common sense is always on our side. So the coordinates of this final point here are -5, comma 4. So negative 5, comma 4. Now let's look for a rule. So we started with the point 4, comma negative 5, right? And then we did this reflection, and we ended up with the point negative 5, comma 4. So what happened to when we did this reflection over the line y equals x, what happened? Well, it looks like all that happened was the x and y just switched places. So in general, if we have x, y, and we do a reflection over the line y equals x, it's just going to become y comma x. All right, they're just going to switch places. All right, so that's good to know. Well, let's check our answer. Make sure I'm as smart as I think I am. And sure enough, negative 5, comma 4 is the answer. And now we've got this little formula that we could use. By the way, I hope you're taking notes to help you when you're taking a quiz later. Okay, I think we're almost done. Yeah, this is the last question. All right, let me get my colors ready. What is the preimage of vertex A prime if the image shown was created by reflection over the y-axis? So this is a y-axis reflection. Here's the image, and we're looking for the preimage. So the y-axis is here. So if I want to find the reflection, which is really what I'm looking for, I'm going to go the same distance on the other side of the y-axis. So notice that this is counting by 2's, 2, 4, 6, 8. So well, looking at the squares, this is 3 squares to the right. So if I go 3 squares to the left, this should be that image. I'm sorry, this is the preimage. You know, this was the original that we just found. Anyway, be careful when you say the coordinates because we're counting by 2's. So this is really the point negative 5, comma 8. All right, now we could make a formula for this like we did for the line y equals x. But I really think just using your common sense is way better. Just doing it visually is better than confusing yourself with formulas. So anyway, negative 5, comma, wait, am I counting wrong? Oh, yeah, not negative 5. Negative 6, right? We're counting by 2's. So I just went negative 4, negative 5, but it's really negative 6. Negative 6. Okay, so negative 6, comma 8. So it should be this guy right here. Boom. There you go. Okay. Now here are the rules for reflections. So I recommend that you go ahead and just pause the screen and pause the video and copy down this chart. And then keep this chart with you as you're taking the next quiz, and it will help you if you need it. If common sense fails, you can use these rules to help you find what's going to happen. So for example, if they said the original point was 2 comma negative 3, what would the new point be? If they say we're reflecting over the line y equals x, then we know just to switch them around. So that would be negative 3 comma 2. If they said no, we're going to use the reflection line y equals negative x. All right, what did I say? 2 comma negative 3. Now this says we're going to switch them around, and these negative signs really mean change the sign. So I would switch them around in the opposite way, but each one will change signs. So this negative 3, when I switch it, will become positive 3. This positive 2 will become a negative 2. So they switch sides and change signs. That's what this means. Okay. If I did the x-axis, this means they don't switch sides, but the y value changes signs. So the 2 would stay the same, because that's the x, but the y would change signs, so it'll become a positive 3, since it used to be a negative 3. And let's see, and the y-axis, 2 comma negative 3. Again, this rule means don't switch them around, just change the sign of the x value. So this would become a negative 2. The negative 3 would just stay a negative 3. Okay, might as well put this one back to complete my little chart. All right, 2, negative 3. We just switched them around, so that was negative 3, comma 2. So the rules will help you if you need them. Copy down the rules and have that little piece of paper next to you when you take your next quiz. All right, I hope this was helpful. Good luck.